Okay, so we're going to start today with rational expressions. Rational basically just means fractional, or being able to be written as a fraction. So if you see something that can be written as a fraction, which is almost anything, whole numbers of course can be written as fractions, then that is rational expression. Alright, so we're going to start off with simplifying them and then move on to multiplying. I guess I should have written that beforehand. And dividing. We're going to do all three of these in one video because all three of these are the exact same operations. So let's get back to something that we know how to do, something like 10 over 16. You can just look at this probably and simplify it. You look at it and you say, okay, well 2 divides into 10 and 2 divides into 16, so I get 5 over 8. But why are you allowed to just divide top and bottom of a fraction by something? Well, basically because that's what a fraction bar means. A fraction bar means divide. So if I look at something like 10 over 16, I could rewrite this. I could rewrite 10 as 5 times 2. I could rewrite 16 as 8 times 2. And I could say, okay, fraction means divide, so 2 divided by 2 would cancel out to 1. So I would just get 5 over 8. This is a much more useful way of looking at algebraic fractions. So say I have something like x squared minus 3x minus 4 and x squared minus 9x plus 20. Now looking at this, I probably don't know what just divides into the top and divides into the bottom. Not really sure. What I do know is that if I could rewrite this as stuff being multiplied, then I could go ahead and just see what canceled. So I'm going to do that. I'm going to go ahead and try to write as stuff being multiplied. We learned for the last one, write as stuff being multiplied would mean to factor. So this is a quadratic. I know it's a quadratic because of the x squared, so I'm going to factor into 2 parentheses. It's just a plain x squared, so I'm going to get x and x. And I'm looking for things that multiply to minus 4 and add to minus 3. So I'm going to go with minus 4 and plus 1. Okay, so I'm going to do the same thing to the denominator. Again, it's a quadratic. I'm going to get x and x. I'm going to look for things that multiply to the plus 20 and add to the minus 9. I'm going to use minus 4 and minus 5. Now if I look at this, I got minus x minus 4 over x minus 4. They should just cancel out. So I will have x plus 1 over x minus 5. This is my answer. I cannot simplify these x's right here. If I was going to try to simplify these x's, they would have to be multiplied. If I have something like 5 plus 2 over 5 plus 3, I can't just cancel out the 5's. If I cancel out the 5's, I'll get 2/3, which is not the same thing I would get if I actually did the problem. So I can only cancel if I have everything be multiplied. Okay, let's try it with the next one. So say I have something like x squared plus 2x minus 24 and x squared plus 3x minus 28. I'm going to start off by, again, just factoring. So I will have quadratic, 2 parentheses, x and x, things that multiply minus 24 and add to plus 2. Again, from last video, we should be able to figure this out pretty okay. Plus 6 minus 4. And I'm going to factor a denominator. Again, it's a quadratic, so 2 binomials, x and x, things that multiply to negative 28, add to positive 3, plus 7 minus 4. So again, my x minus 4's happen to be the ones that cancel out. So I'm just going to be left with x plus 6 over x plus 7. And I'm done. Okay, so let's look at multiplying. Hopefully you remember how to multiply fractions. When you multiply fractions like 1/2 times, let's say, 5/3, you just multiply straight across the top and straight across the bottom. And you simplify if you can. So when I'm multiplying these, if I have something like x squared plus x minus 2 over x squared minus 1 times x squared plus 6x plus 5 over x squared plus 2x minus 15, I can write this as one big fraction with everything being multiplied. So x squared plus x minus 2 times x squared plus 6x plus 5 over x squared minus 1 times x squared plus 2x minus 15. Now I could multiply this out, but since, as I said, I want to multiply and then see if stuff can be simplified, and I know that if I'm going to simplify, then I'm going to have to factor. Instead of multiplying this out, I'm just going to factor everything and see if anything cancels. Got a bunch of quadratics, so I'm going to end up with a bunch of binomials. First quadratic is x squared plus x minus 2. I'm going to go with x plus 2, x minus 1. Second quadratic on the top is x squared plus 6x plus 5. So I'm going to go with x plus 5, x plus 1. First quadratic in the denominator is x squared minus 1. So I'll get x plus 1, x minus 1. Second quadratic in the denominator, x squared plus 5x minus 15. So I'll get x plus 5 and x minus 3. And I'm going to see what can cancel. So x plus 5 over x plus 5, x minus 1 over x minus 1, and x plus 1 over x plus 1. So I'm just left with x plus 2 over x minus 3. So dividing is very similar to multiplying fractions. Dividing, again, we're going to go back to numbers. Say I have something like 1/2 divided by 5/3. Hopefully you remember how to divide fractions. To divide fractions, you just flip the second one and multiply. So when we're dividing fractions, all we have to do is flip the second one and multiply. So we'll do that. I'm going to get x squared minus 3x. That's going to be on top. I'm going to write one big fraction bar. And I'm going to flip the second one, so I'm also going to have x squared plus 9x plus 20 on top. On bottom, I will have x squared plus x minus 12. Since I flipped it, I'm also going to have 2x plus 10. Now I'm multiplying, so I wrote it as one big fraction being multiplied. Again, this is all quadratics, so I'm going to go ahead and see what I can factor. So let's see, x squared minus 3x, that's a quadratic. I don't have a third term, I'm missing this constant term. Since I'm missing that constant term, that means I can pull out an x. So x times x minus 3. Okay, my second quadratic, and the numerator is x squared plus 9x plus 20. That time I have all three terms, so I'm going to factor in the two binomials, x and x, plus 5 plus 4. Okay, my denominator, x squared plus x minus 12. It's a quadratic. I'm going to factor it to two binomials, so x plus 4, x minus 3, and 2x plus 10. That's not a quadratic. Obviously, I was wrong earlier. This is not a quadratic. It doesn't have the x squared. So I'm just going to see what I can factor out of it. What can I pull out of it? So 2x plus 10, the 2 would come out of it, and I'd be left with x plus 5. Okay, so let's see. X minus 3's will cancel, x plus 5's will cancel, and x plus 4's will cancel. So I'm just left with x over 2. And that's it. That thing simplified pretty nicely. Let's try the last one. 6x squared minus x minus 2 over 3x squared minus 14x plus 8 divided by 4x squared minus 1. And you notice that this 4x squared minus 1 is in parentheses. That's to show it's being divided by this whole binomial. I didn't need the parentheses previously because it was being divided by the whole fraction. So I'm going to write this as a fraction so we can still flip and multiply. I'm going to write this fraction the same way we write 7 as a fraction. I'm just going to put it over 1. Okay, so let's see. I'll have 6x squared minus x minus 2 on top. I'm going to write this as one big fraction. And I'll have, well, 1 on top. Okay, that's not going to do much to it. I'll have 3x squared minus 14x plus 8. And I'll have 4x squared minus 1. So obviously we can't forget how to factor. We have a number in front of the x squared. We learned quite a few ways of doing this, so take your time. You can pause this and try to actually factor this. I'm going to do it by, well, trial and error more in my head. So on top I just have the 6x squared minus x minus 2. Let's see, I'm going to go ahead and try a 3x and a 2x. I know that that will multiply to give me the 6x squared. And I know that with my minus 2, I'm probably going to have a 2 and a 1. So I'm just going to play around with the numbers. I'm going to try my 2 with my 3 and my 1 here. If I do that, I'll get 2 times 2 is at 4x, and 3 times 1 is at 3x. So they would add, if I make that negative and that one positive, to give me a minus 1x. Again, factor them however felt most comfortable for you. I'm going to go through the next one a little quicker. 3x squared minus 14x plus 8. It's got to be a 3x and an x. Need to be the same sign because I'm multiplying to a positive 8, adding to a negative, so it's going to be negative and negative. 8 would give me 4 and 2. That would work because 3 times 4 would be 12. And 2 times 1 would be 2. 2 plus 12 would give me my minus 14x. Okay, last one is missing that middle term, so this is going to be just a difference of two perfect squares. So square root of 4x squared is 2x, square root of 1 is minus 1, and 2x plus 1. Okay, everything's factored, and I didn't write that 1 anymore. I didn't need it. If I multiply stuff by 1, it's the same thing, so I don't actually need it. Though I did just write it again. Oh well. Well, my 3x minus 2 cancels, 2x plus 1s cancel. Since everything canceled in the numerator, I would just be left with a 1. They would divide out to 1 in the numerator. And x minus 4, 2x minus 1 in the denominator. Okay, can't simplify anymore, and there's no sense of multiplying this out. You might as well keep it factored. Hope that worked. We'll look at adding and subtracting these next.